Okay, in this tutorial, I'm going to try to convince you that functions are more useful rather than more painful. So, let's say I want to make a prime number here. Let's say n is equal to 13. And I want to know if it's prime or not. So I'm going to use a for loop. And let me just type this up real quick. We've already seen a prime number algorithm here, but we used while loops here. So I'm going to go ahead and post that link here if you want to see what how the prime number works here. But this is just going to be the same thing here. So if n divided by the value of a is equal to 0 here, which means if the remainder is 0, we are going to output n, we're going to say, is not prime. And then we're done. We already know it's not prime. We're going to break out of the for loop. But actually, let's check to see if a equals n first. Because if a equals n, then it's prime. If a is equal to n here, oops, then we can say a is equal to cout n is prime. Okay. Now, so let's run this here. Now, this isn't the most efficient code here. I want to set this equal to 2 first. Okay. I'm having a couple problems here because I forgot to initialize a variable, and nothing happens. And the only reason why, because I didn't put an equal here, because it'll never get the chance to see if it's equal. Okay. All right. So 13 is prime. 13 is not prime. And the reason why I said that is because I didn't put breaks here. Okay. Now here's the running version here. 13 is prime. If I put 12, it's going to say 13 is not prime. Alright, well, what if we want to run through a cycle of numbers here? Let's say we could put this whole thing in a while loop here. But then we got to set n back equal to whatever, and we'll have to do a couple things here. Well, so here's the algorithm for prime numbers here. What if somewhere along the code I wanted to find out if another value was prime? I would have to retype this code again, and I really don't want to do that if I want to figure out if a number is prime more than once. I don't want to retype all this again because there's a good chance that I can mess it up. You know, I can have all the errors that I had just like I just had in the past here. So what I want to do, I want to make a function here that's going to tell me if it's prime or not. So this is so I don't have to type all this up again. So let's say a boolean here, and I call it prime. And I want it to take an integer value here. Let's just say I call it n for right now. And so it's going to take one parameter of n. Now, let's just say I do the same exact thing here. I want to copy and paste this here. I paste it right in here. So inside this function here, I got this algorithm here. Now, I don't want it to print out if it's prime or not. Because if this thing is prime here, I want it to return true. Now, if it's not prime, I want it to return false. Uh, okay, so this is it here. It's either going to return true or false in here, depending on this condition. And then, so let's say I call this function here. I want to output prime. Let's say I got to enter an integer value here. Let's say I enter 12 here. Now remember, if I output booleans here, it's going to either output a true or a false here. So look, it's going to either run through here, it's either going to return a true or a false in this function here. In this case, it returned a 0 here. That means it's false. 12 is not prime. In other words, I can put 13 here, and it should return a 1 here. Because in this algorithm, 1 is prime here. Okay, so let me apply this here. What if I want to run through a series of numbers here? So let me make another variable called, I'm going to call it number here. Number is equal to 2. Now, let's say I make a while loop here. So while, let's say number is less than 100 here. Then what if I only want to print prime numbers to the screen? Okay, in this case, let's say I only want to print the prime numbers that are to the screen here, from 1 to 100 here. So I'm going to say if prime of n here. Or let me say number here. So remember, this is a boolean here, so it's going to check this whole thing is either going to be true or false here from the return value. Because these are only going to evaluate the return value here. So I don't have to, I can do this if I want to. If it makes more sense to you, you can go ahead and do this. If this is equal to true here. Now, if this is equal to true, it'll only output prime numbers here. But I can put this here because it's either going to be true or false anyway. Now, I want to output number. So we'll run this here. Now we can call this function over and over and over. And I want to increment it. And I could have also used a for loop here. Okay, so let's trace this carefully. So this algorithm is going to print only prime numbers to the screen here. Okay. Also, let's see if it's got to check to see if this. So we're going to look through here. So first number starts off at 2 here. Then, so we're going to see if 2 is prime here. So when it goes through here, when the program sees this here, it's going to jump all the way up to here. And it's going to execute this code here. And it's going to figure out if it's prime or not. In this case, 2 is going to return true because it's prime here. Now we can have another case for if n is equal to 1 here. We can return false. But since that's a special case, because 1 by definition isn't prime, but we can still check that. That way we can see if we're getting 1 or not. Then we can set number equal to 1. So we can go back to the main function and set this equal to 1 here. So keep in mind that this code up here, remember this is just a function here. And the compiler is always going to enter the main function first. And these are just this is just basically our own little function that we made that we can call whenever we'd like. And when the compiler sees this here, it's going to go jump to that function and return the value here. So maybe if we want to say it's not prime, let's say if this is equal to false, then we can print numbers that are not prime to the screen. So in this case, it does it. It prints all the numbers except the prime numbers here. It doesn't print the prime numbers in this case. Or we can just print the prime numbers to see if it's true. So we know that we only have to type this code up once here. And we can use it 1,000 times, or we can use it 10,000 times here to call a function here. So in this case, these are all the prime numbers here. So I just printed 1,000 prime numbers here. Now we can only look back so far here. But I'll go over file input and output later on when I get into the later lessons here. Now at this point here, since we already got a lot of the stuff down here, once we learn functions here, you can basically skip to whatever lesson you want here, and you wouldn't have to follow them in order. I mean, when you first learn the language here, it was important that you watch the videos in order. Now since we're getting kind of far here, you should be able to skip to certain lessons that are of interest here. So if you want to learn about how to output stuff to the screen here, you can just jump to that lesson here. And you can also go to the library. Here I have a little library here. It just basically has all my videos. You can see the titles and you can watch every one you want. They should be easy to find here. So we have an idea of how functions work here. So we can call these functions over here. And keep in mind that this right here is only going to evaluate the return value here. So depending on what the return value is what it's going to be evaluated at. Now let me go over one more function here. So this is just a prime number function here. So we only have to write the algorithm just to generate one prime number. So I'm only looking to see if one number is prime or not. Then I can use all kinds of while loops and stuff to use it over and over. Okay, so I'm going to keep that function there because I might want to use it again one day. So you don't have to delete it all. I want to make another function. Let's call it, now this function here, this is going to be new, it's going to be called void. And basically, let's say I call it a function here. I want to call it h. Oh, whoa. I just want to call it h here. Just to show you as an example here. Cout, and I'm going to print out hello world. And void functions do not need a return type. So if you don't want to return anything, maybe you just want to print something out to the screen, you can call this function here. So maybe I want to call, say, h here. I call it. And then it runs the rest of the code. And maybe we want to call it at the end so we can see it. Okay, then it says hello world, so I don't have to type in hello world ever again because I made a function that does that for me. Now it's kind of, maybe that might not be one you want to use, but you can use void if you don't want to return anything, you just want to execute things. So that's what we have here. So that's just an intro to void here, and then I'll go over another function later in the next tutorial, actually. So I'm gonna close this one, and maybe we want to go over a little bit more on random numbers here to use functions from that.